Chapter 8, multi-dimensional arrays, two-dimensional arrays. Some people are probably thinking, no, let's not even go there, but it will be fun. It's going to be easy. Let's jump right in. So a lot of stuff we want to accomplish, just covering the overall idea of what's a 2D array, what is really stored inside a two-dimensional array. We're going to do a lot of processing of those things. We're going to sum the values by rows, by columns. We're going to print the arrays, all kinds of fun stuff. It's going to be easy. So the previous chapter we covered one-dimensional arrays. So imagine we have this 1D array that's going to store flight distances from Chicago to a variety of other cities. So you see here that Chicago to Chicago, of course, should be 0 miles. Chicago to Boston, we have 983 miles. Chicago over to, for example, Dallas, 967 miles. This is a typical representation of a single row, a one-dimensional array, right? Chicago to all of those other cities. Well, we can expand upon that, and now we can get not just Chicago to other cities, but many cities to all of the other different cities. And so this is this table format. And so now we have many rows, many columns. This is really the idea of a two-dimensional array. And if you notice now, if we look at, for example, New York to Chicago, 787 miles, where you see the cursor. Also, Chicago to New York in that very first row, or row index 0, 787 miles, right? So it's repeated. We have Miami going over to Atlanta, 661 miles. If you come find Atlanta, Atlanta can go to Miami, also 661 miles, right? And of course, each of the cities, the distance to itself from Miami to Miami should be 0. So here's an example, a depiction of a two-dimensional data structure. This one was depicted maybe in Excel using a table type of a format, but a two-dimensional structure where we're showing rows and columns. And here is how we could have saved all of that data. Just a quick bird's eye view, we could have saved all of this into a two-dimensional array of doubles, where we're using that shortcut notation and we're directly saving all of the data in. And how many rows is this? 1, 2, 3, 4, 5, 6, 7 rows by 7 columns. We could have said equals new array 7 by 7, and then one by one, put these 49 values into the array. That would be a disaster. So instead, on this example, you see we can save the data right in. So now let's get into more of the nuts and bolts of this. So an element in a two-dimensional array is accessed through both a row index as well as a column index. The syntax to declare an array is what we've already seen. The only difference is now with it being a two-dimensional array, instead of having only one pair of these square brackets, now we have 2 pairs, right? We have int bracket, 2 of them. Matrix, for example, it's appropriately called since it's a matrix. You can also create the actual array and then assign the reference into that variable matrix in the exact same way that you do for one-dimensional arrays. So here, if I said new int and we had 5 by 5, that's going to create an array with 5 rows and an array with 5 columns for a total of 25 cells inside this two-dimensional array. So we can also always declare and create the array in one step, as we already know and have seen previously with one-dimensional arrays. Here I've created on the right side of the assignment a new double. How many rows? 200 rows by 200 columns. That's a lot of cells. And we save all of that into this variable matrix. Now, as with one-dimensional arrays, what's really getting saved into variable matrix? An address, a reference to this two-dimensional structure on the heap, but it's more nuanced than that, and it's super important. We're going to talk about that in just a couple of minutes. So here's another example. You see here, we made this new int 5 by 5 array. Here's a depiction, and this first 5 is the number of rows. So this shows 5 rows from index 0 all the way to index 4. Those are the row indices. And then we have the columns, also 5, from index 0 to index 4. Now, if you notice here on the right side, what are we doing? We're saying let's save a 7 into a particular index. Which index? row index 2. So here's row 2 right here, row index 2, and then column index 1. And here's column 1. So row index 2, column 1, and you save the 7 right there. So a common mistake is to flip row and column. Which comes first? We put the row first or the column first? Just you'll have to get practice with that and remember the first value is the row index. The second value is the column index. So we're saving the 7 at row 2, row index 2, column index 1. And so as we showed on that first bird's eye view example of those cities, here we can use that array initializer to in one go, instead of creating, so here what do we have? Let's count the number of rows. We have actually 4 rows here, and each row has 3 integers. So this is really a 4 by 3 array. So these are equivalent. If you looked over here, I could have said int and then put 2 pair of brackets, array equals new int 4, 3. So now we have a total of 12 cells, 4 rows by 3 columns, and then one by one I could have saved each value into that specific cell. Let's actually look at one of these. This 9, let's look at the 12. Where is this 12 saved? It's at row index 3. Remember, we start at row 0, well, row 1, row 2, row 3, row index 3, and this is column index 2. So at row 3, column 2, we could have saved the 12. We could have saved this 5 into, what is that? That's row index 1, column index 1. We could have done that right here. Or we can just use the array initializer. It's not very common because the use cases for the array initializer are usually minimal. Nevertheless, it's important to know that that exists and that we can use it. So here's what's wacky. Because we just talked about two-dimensional arrays, right? But what's really wacky about it is that a two-dimensional array is actually an array in which each element of that array is a reference to a one-dimensional array. Did that even make sense? Let me repeat that. A two-dimensional array is really a one-dimensional array of references where each reference points to an array of one dimension, which then would store whatever type of data type you've asked it, a one-dimensional array of integers. So that's crazy, and I'm going to repeat that. We're going to show an example. So more clearly stated, a two-dimensional array variable contains an address, right? We just showed you on the previous page, right? This variable array, it contains an address. An address to what? Well, for now, we would have said an address to a two-dimensional array on the heap. But in fact, this two-dimensional array variable, it contains an address to a one-dimensional array that is stored on the heap, and each cell of that one-dimensional array contains a reference that in turn points to a one-dimensional array of values. I agree with the GIF, like what? So it's nice to be able to see a depiction of this, and we'll go through it some more. So here if we say new int 3, 4, this is 3 rows by 4 columns. What's actually stored at index 0 or index 1 or index 2? And notice I didn't put 2 pairs of brackets here. There's only 1 pair of bracket. What's actually going on? We said a two-dimensional array is really a one-dimensional array of size 3 here, the number of rows. It's a one-dimensional array. So what's stored inside X? Here's X. What's stored inside X? It's actually an address that points over to a one-dimensional array of size 3. Therefore, X.length is 3, referring to the number of rows. This is a one-dimensional array of size 3. Now, what's stored right here at X0? The answer is an address that points to a one-dimensional array of size 4 of what data type? Integer. So this is going to be a one-dimensional array of size 4 integers. It's not hard, it's just weird, right? Definitely it's weird. So this is a one-dimensional array of 4 integers. What's stored right here at X2, at index 2 of X? Because remember, X is really a one-dimensional array of addresses or of references. What's stored at X2? An address that refers to this one-dimensional array again of size 4. So here's an interesting nuance that how do we get the length, if you recall, how do we get the length of an array? We just say that array.length. If I were to say int bracket x equals new int of size 5. How do I get the length of x? I just print x.length, and that will print for me 5. Well, now when we have a two-dimensional array, let's say this double, 2 dimensions, y equals new double, and let's make this 8 by 12. When I print y.length, what actually gets printed? The answer is we're printing the size of that one-dimensional array, or you could say we're printing the number of rows of this particular two-dimensional array. So we print out 8. Well, how do we know for a given row, so this is 8 rows, how do we know for a given row how many cells are in that row? We can then print out y at a particular row. How about y at row 4? Because we know there's already 8 rows from row index 0 to row index 7. Let's go to row index 7. If we know that it's 8 rows, right, it's going to be index 0 to index 7. So we can go to row 7 dot length. And what will that do? That will give us the length of this one-dimensional array of actual values. And this will print for us 12. So it's funky, no doubt, but if we just give it a moment, chew on that a bit, hopefully it'll make sense. So yes, a two-dimensional array, easy to visualize, and I could have left it at that, but it's important to really understand what's under the hood, that it's really this value x stores an address to a one-dimensional array, and then each value inside that one-dimensional array in turn has an address right here at index 1 that points over to this one-dimensional array of size 4 integers on the heap. And for clarity, this one-dimensional array of size 3 of references, that's on the heap, and each of these one-dimensional arrays of size 4 are also on the heap. And so we see here again, x.length is 3, that's the number of rows, and then for each individual row, x at index 0 is 4, x at index 1.length is 4, and of course x at index 2.length is 4. Really funky. If you're still feeling this way, I hear you. Can take a moment to really let that sink in. Now, because each index of that one-dimensional array of rows, because each one is really pointing to its own one-dimensional array of values, what that means is we can actually get different sizes for each of those one-dimensional array of values. Again, not common, but it's something that we can be aware of. This is called a ragged array. So look, if we declare, using the array initializer, if we declare this array called triangle array. In the first row, we store 1, 2, 3, 4, 5. In the second row, we store 2, 3, 4, 5. In the third row, 3, 4, 5. In the fourth, 4, 5. And then in the fifth row, which is row index 4, we just put the value 5. So because we recognize that this particular two-dimensional array is really a one-dimensional array of size 5, where each of these indices of this one-dimensional array of size 5 stores an address to a one-dimensional array, because we know that now from the previous slide, that each of these one-dimensional arrays, yeah, it's okay if they're different sizes. And in fact, that's what we're depicting here. So if we print out the length of triangle array at index 0, so row 0, what's the length of row 0? How many cells are in row 0, or how many columns are in row 0? The answer is 5. How many are in row index 1? The answer is 4. What is the length of, or the number of cells of row index right here? 4. This is 0, 1, 2, 3, 4. Row index 4, well, the size of that one-dimensional array is only 5. This is a ragged array. So also, what if at the beginning, if you'd like, you know what, I don't know how big the individual rows are going to be. You could just do this. You could say int bracket, let's call this z equals new int. Let's say we want to have 10 rows. Let's make it 5 rows. But we don't know we don't know the size of each of those other rows. In fact, I'm not even creating them right now, because here, like if I had said 5 by 6, that would have been 30 total cells, 5 rows. Each row would have 6 cells in it. But what if I put this right here? What does that mean? Well, this says I have a one-dimensional array of size 5, and each of those addresses within that one-dimensional array, they're not currently pointing to anything, which is super funky. Let's actually draw that out for us. Let me come back to here, hit home, 2D array stuff. Oh, no, let's do that again. 2D array stuff. So if we said x, we had z, int, bracket, 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 z equals new int of size, we said 5, and then nothing. What's actually happening? Remember, so now we have z. What is z? Z is a local variable on the stack that's going to point to, on the heap, a one-dimensional array of references. I'm going to draw this vertically by design. So this is going to be index 0, 1, 2, 3, 4. Now, what's stored in here right now? At each one of these indices is a reference that's currently pointing to nothing. It's pointing to null. Each one. And so now, what if we came back and we said, okay, let's actually change this. Or let's make a new array. And I want to say, how about we say z at index 3. Oh my goodness. Z at index 3. Let's make a new one-dimensional array of size 7. Why not? So what's going to happen there? Let's depict this. Well, z at index 3. Here's index 3 right here. What are we going to do at index 3? We're going to make a one-dimensional array of size 7. Did I do that right? 0, 1, 2, 3, 4, 5, 6. That's size 7. And now what's actually stored at index 3 is a reference that points over to this one-dimensional array of size 7. Super funky, like no doubt. This is initially confusing, just playing with my Stream Deck, but it's not that bad. And it's actually cool once you begin to use it and understand how it actually works. So as we mentioned, we could have made this array of size 5 rows, not put any value for the second dimension, the number of cells per row, and then yeah, we could just explicitly state at row 0, I want to make a new array of size 5. At row 1, a new array of size 4. This is really doing the same thing as on the previous slide, but now instead of using the array initializer, we're doing it step by step. So here's a checkpoint. What is the output of the following? Int, bracket, bracket, so it's a two-dimensional array, equals new int 5, 6. Then we say int bracket x equals 1, 2. So what is x? X is a one-dimensional array of size of one-dimensional array. What's contained in x? 2 values, 1 and 2. Now check this out. This is funky. Array index 0 equals x. And now we want to print array 0, 1 is array 0, 1. That's funky. Let's take a look at that one and see what's actually happening with that. So through the magic of technology called a pause button, we are here at the tablet. Look at what's already drawn out. We have this two-dimensional array of size 5 rows from 0, row index 0 to row index 4, and each one is pointing to, as we know, here we have where each row, the length is going to be 6. So each of these will be length 6, right? We have 5 rows where each row is length 6. So what happens next? Here it says int x equals, so x equals, and then we have this one-dimensional array of 1 by 2. So on the heap, we're going to get this one-dimensional array, index 0, index 1. What's going to be stored inside that array? The value 1, the value 2. And now we have an assignment. We're working from right to left. We have an assignment. That the address of that one-dimensional array gets saved into X. And here's the address, depicting it with an asterisk. And what gets saved into X? The address of the beginning of that array in memory on the heap. Cool. What happens on the third line is what's interesting. It says take what is in X and save it right here. Save whatever's in X and save it over here at index 0, one dimension, index 0 of the array called array. Well, what's inside X right now? What's actually inside X? It's an address. An address to what? An address to that one-dimensional array on the heap. So this line up here, it says take whatever's inside X, that address, and store it right here at index 0, which means the address of that one-dimensional array is going to be stored over here at index 0, the consequence of which is what? Let me erase some of these other things. Let me hit back there. Let me erase this. Erase this. Cool. Erase that. So the consequence of what? Of this statement right here. Take X and save it into array at index 0. What's in X? An address. The address of what? The address of that array. We'll take the address of that array, which is stored inside X right here. Take that address and store it inside index 0 right here. The consequence of which is what? That this index 0 is going to point directly over to that one-dimensional array of size 2. And this index 0 right here is no longer pointing to this one-dimensional array of size 6. And as we've said before, the Java garbage collector has absolutely zero mercy, so that array will be immediately thrown away. And this is what happens with this particular checkpoint. Really cool to understand what's going on, that we have a two-dimensional array is really a one-dimensional array of references. So here, this is saying which of the following statements are valid. Let's go through these quickly. Can we make a two-dimensional array like this? No, we can't. You cannot just put bracket 2, or let me come back to the actual PowerPoint. So here we cannot just put a 2. We have to have another pair of brackets, whether they be empty or value inside representing the length of each of those rows, but you have to have that second pair when you use it like this. Is this a valid syntax? The answer is no, because this is just a one-dimensional array. We're not specifying the length we need to. What about this one? On the two-dimensional array, can we use this syntax? We just saw we can. We can specify the number of rows, and we don't need to specify the number of columns per row. What about this syntax? This is just an array initializer. It's going to be a two-dimensional array, but what's really inside this two-dimensional array? Just a single row, and that single row has 2 columns. Here, on this 5th example, we have here a two-dimensional array of 2 rows, where each row has 2 columns. In this 3rd example, it's actually invalid because we have comma, and we're not showing any 3rd row there, so that comma should not be there. Okay, so we want to solve this problem here. We want to create an array within a method. We then want to have another method that's going to print that array, and then finally a 3rd method where we're going to sum up all the values within this two-dimensional array and return that sum. So it's a great practice of getting back to methods and arrays, and what are we sending really to a method? When we send an array to a method, we're sending an address. That's with one-dimensional arrays. With two-dimensional arrays, it's the exact same thing. We're simply sending over an address. And when we return an array from a method, we are merely returning that address. So we want to go through this example and code this up together. So let me just erase what I have here. Two-dimensional array processing. And we want to write a method that's going to create a two-dimensional array and return its reference. So let's just code that up first. And let me zoom in so this can be seen. Public, static, and it's going to return a reference. So I'm going to put here return type, and we'll get to that in a moment. And what is this method called? Create array. And there's no parameters, nothing inside there at all. And we want to create array, and this will be of random values. So we want to make a random RNG equals new random. And let's go ahead and set the seed so we'll have the same numbers. RNG.setSeed. Let's pick the value 823. Sure. And let's now make our array. So declare and initialize an array of size what? How about we do a 5 by 7? And so now int bracket ARR equals new int 5 rows by 7 columns. And now we're just going to loop over all of those rows. This is the part that's going to be new for us, using not one loop, but 2 loops to loop over this two-dimensional array. Now, by default here in NetBeans, when just let me get back to the for loop in a moment. A lot of us don't like this red up here shouting at us. It hurts our feelings. So what is the return type? Well, we're creating an array, a two-dimensional array, but what's really inside this? It's an address. It's an address to what? Really, it's a one-dimensional array of references, but in the end, what gets returned is, I'm going to type down here, return ARR when I'm done. So I need to return the array. But what's really being returned is what? We are returning the address of that one-dimensional array. So that is the correct way to understand it, but in fact, here, when we type it, you will put int bracket because it's still understood as the whole thing is a two-dimensional array. So that's the return type. Let's get back to the for loop. We want to loop over this entire 5 by 7 array, okay? And when we loop over it, we're going to start by looping over the rows. And notice in NetBeans, when I just type in FOR tab, it gives me this variable I, as we've seen for weeks now. No problem, but I want to rename that to something more meaningful considering what I'm looping over. So when I click I, I'm going to literally just click to the right of I or the left of I, doesn't matter. Notice this little box around I, right? Hit Control R or Command R perhaps on a Mac, and now it highlights all of those I's, and I'm going to type ROW, enter. It's just a quick and easy way of changing the name of all of those instances of the variable I. So I'm going to loop over the number of rows starting at row index 0 and going all the way up to row index 5, but not to 5, from 0 to 4. Now, for each of those rows, now I'm at row index 0. What do I want to do? I want to loop over the columns. So let's put some comments. Loop over each row. And now, for each row, loop over each cell or column value. I'll say loop over each cell in that row. So for, and once again, when I typed in FOR tab, it put an I. I'm going to click the I, I'm going to hit Control R, and I'm going to call this call for column. So now it says int call equals 0 as long as my column is less than what? Well, how many rows did I have? I had 5 rows. 7 columns from index 0 to 6. So I'm going to put here less than 7. So we're going to loop over the rows from row index 0 to 4. And then for each row, we're going to loop over the columns from column index 0 to column index 6. And when I do that, this looks good now. And we want to simply do what? At every step of this for loop, we want to generate a random number and save it into the appropriate cell of this array, of this 2D array. Let me zoom out some. There we go. Cool. So first, let's go ahead and generate this random number. So let me make an integer up here, int random value. And then right here, I'm going to generate random value equals rng.nextInt. Let's make this between, how about 50 and 100, 50 and 101. So we have our next int between 50, and let's make it between 50 and exactly 99. So 50 and 100, not including 100. And what do we want to do with this random value? We want to save it inside a particular index. I want to save it. I'm going to put an assignment. I'm working backwards. I want to let you visualize we're starting on the right of the assignment. We're working backwards. We want to save it into a particular index of this two-dimensional array. We want to save it at some index, right? The first time we want to save it at index 0, 1. I'm sorry, 0, 0. Row 0, column 0. Then row 0, column 1. Then row 0, column 2, column 3, column 4, column 5, and then column 6. After saving it at index row 0 and then column 6, we want to go to row 1, column 0. And then row 1, column 2, column 3, column 4, column 5, column 6. Then we want to go to row 2, column 0, column 1, column 2, column 3, column 4, column 5, column 6. I hope we get the idea. So what are we going to put here? We're going to put here row. And then right here, I'm going to put here column. Because that's what this outer for loop is doing, and this inner for loop looping over the columns. That's precisely what it's doing. So we have generated all these random values, and I did not need to do this in 2 lines. I could have, of course, just taken this one line right here and put it right here and gotten rid of this. Most of you are fine with that, but sometimes it helps to see that over 2 lines so it's not too confusing of what's actually going on when we're going to break it down. So we've now created this for loop. We've written this for loop. We've generated all those values. We are returning the array. The other thing it said is we need to now print that array. So let's write a method to print that array. We haven't even touched our main. We're just writing methods here to print the array. Public static void print array, because we're not returning anything, but instead, what are we doing? We're sending to this method a two-dimensional array, which means we're really sending over an address, as we know. So what are we going to do here? We're going to do the exact same 2 for loops. But you know what? Let me come up here and change these for loops first. I meant to actually edit one thing. So hopefully we understand that this is looping from 0 to 5, and this inner one loops from 0 to 7. But we want our code to be more general than this, right? Because what if this was from 6 to 12, right? What would we have done? Then we'd have to come change this to 6 to 12, right? So we don't want to do that. Instead, when we do this for loop, as we know, we want to have it more general. So this we would have said arr.length, which is what we would traditionally do with a one-dimensional array. Well, even when we're looping over the number of rows, that's what we get. arr.length, as we showed you previously, that will give you the number of rows. So that's perfect. Well, how many cells per row? Well, we know it's 7 cells per row, but how did we do that? We said it's arr at index, for example, 0, that's row 0. How many cells are in that row, or what is the length of row 0? You specify a row 0 right here, and then you say dot length. So see that difference, that distinction. Here, this is the length of the number of rows, and this is the length of row 0. Now, this is going to work fine. I could leave it as is because all of our rows have this exact same length. So even when we increment row to 1, it's okay that we're still checking the length of row 0 because they're all the same length, right? In that second dimension, all of those rows have the exact same length. But if you had a ragged array where the rows had different lengths, this of course would not work. We would want to put here for row 0, we'd want to check row 0 length. For row 1, we'd want to check the length of row 1. For row 2, the length of row 2. For row 3, the length of row 3. And then finally, for row index 4, we want to put the length of row 4. Well, how can we do that? Just put the row variable. And this is now the cleaner, more general code. So with that in mind, now when we're printing an array, it's the exact same for loops. We're going to loop over the number of rows. For each row, we're going to loop over the number of columns. And then we're going to print that value. So check this out. I'm going to highlight all of that. I'm going to paste it right here. Looping over each row. For each row, loop over each cell in that row. Done. But now, I'm not generating anything, so I can delete these 2 lines. And what am I doing? I'm really printing. What am I printing? I'm going to print this value. Array at index row index call, where row and call are the variables of those for loops immediately above. So here I'm going to be printing I'm going to use formatted printing, and I want to print percent, I want to print, pardon me, percent, I want to right align it, so 5D, and I do not want to put a new line, comma, and that's what I want to print. Now, if I just run this, of course, I haven't called anything, so it's not going to show anything yet. Well, that's a big brain moment. I love the big brain moment. That was a big brain. Where's my big brain? Yeah. I'm trying to run this without actually having a main. That's fantastic. So here, if I were to run this, nothing would, it would print out on one huge line, right? Because I didn't put any new lines yet. I want to print one row right here. And then after that row is printed, right? Here's one row right here. After we print a row, I'm going to put this in caps. After one row is printed, do what? Print a new line. Done. So this is printing one row, all of the cells in that row. We don't want to put a new line between every single cell. But now, after that entire row has printed, now, or all the cells in that row are printed, now print a new line. So this is going to work perfectly for us. And what we need to do now is, in our main, we need to call these things. So the first thing we need to do is call this create array method. So here, if I just type in create array, what are we doing? We're calling this method. We're sending nothing to it, right? There are no parameters to be sent. This method creates the array as we discussed, and it returns it. Which means what? Since it's returning this array, two-dimensional array, we need to catch it. We can't just not save it into a variable. We could. There's nothing wrong, but nothing's going to happen. That's a fail. So we want to save the result of this call to create array into a variable. Let's call it address of newly created 2D array. What a huge variable name, just to make sure that we understand what's going on. We're returning the address of the newly created array. That's what gets returned right here within this create array method. We're returning that address, and it's an address to a two-dimensional array of values. And so we're going to save that into this variable name, address of newly created array. But what's the data type? Is it a string? No. Is it an int? No. Is it a double? No. Let's go back to int, because it was a two-dimensional array of integers, right? We're returning a two-dimensional array of integers. So even we can't put, it's not an int, but we can't even say int one-dimensional array, because that's not correct. We have to put that second pair of brackets. So this is saying return the reference to a two-dimensional array that we just made on the heap, save it into that address. Now we can call the print array method. Print array, and when I just hit enter, it'll assume that we want to send over that reference because that's the only two-dimensional reference we have. So let's run this now. And you should get the exact same values with the assumption that you use the same seed, 823. We should have the exact same values, and here's this two-dimensional array that we just made, and hopefully that's clear. The main thing that's going to be not so much new, because when we've studied Python previously, we did cover two-dimensional arrays or two-dimensional lists, but we don't usually get extensive practice with that. We're about to get a lot of extensive practice with both one-dimensional arrays and two-dimensional arrays. And so here, the overall idea that's usually challenging for new learners is this idea of first looping over all of the rows, and then for each row, looping over all of the cells within that particular row. That's what's a little bit unique at first, this idea of these two nested loops that make that happen for us. So the final thing that it said here was to print just the sum of all of those elements. So I want to do this. The sum of the elements in this 2D array is %d period new line. And then here I want to put a number. Like I want it to print some sum. Well, how do I get that sum? I need to call the method sum. And what am I going to send to that method? I'm going to send this address of this two-dimensional array that I just created. Let me zoom out so it fits. There we go. I want to call that method and send over this address right here. So now we need to make that method. So here, if you click right here, it'll say, well, where's the error? I want it to actually make it for us. Cannot find symbol method sum. Oh, come on, I clicked the wrong thing. Cannot find symbol method sum. Oh, I was hoping it would make it for us. It's not playing nicely. That's okay. I'm curious though. Let me bring this on a separate line above. Because normally, when you try to do this, it'll realize you don't have this method, and it'll offer to make it for you. There it goes. Create method sum int. But I would have had to have said int sum equals. So now if you do this, it'll actually just type that for you. Create method. So you see right here, it makes this method, but it makes it private. We haven't studied private. It also puts this in here, which can be confusing. But it saves you from typing the parameter and the return type and the word static. Maybe not the most helpful. So let's go back to where we were. We need to make this method sum. I want to make sure I've copied that name. I do not want to retype that hideous name. Public static. We're returning the sum, so return int. And the name of the method is sum. What's the parameter? It's a two-dimensional array. So you need two pairs of those brackets. And there's the name. And what are we going to do here? And you know what? I may as well just call this ARR. I can change the name. And what's going to go on here? I need to make a sum variable. Ultimately, I need to return that sum. And what happens in the middle? It's the exact same two for loops. I'm going to highlight these two for loops. I'm going to paste them. And what happens here, instead of printing, I'm not going to be printing anything. Instead of printing, what am I doing? I need to, at every iteration, I need to take this value, the value at array, at index row, index call, and I need to add it to my sum. I need to add it to my sum value. It's the exact same two for loops. That's what's nice about this array processing. So once this is done, let's make this a printf. We should be able to run this, and we get the sum of all elements in this 2D array is 2, 6, 2, 4. Hopefully you get that same value. Hopefully I didn't make a mistake there, because that would be fantastic. I think we are absolutely good. So let's come back here. We've coded those up here on the slide. If you just want to see, here's something I had coded previously. It should look pretty similar to what we just did. We have the create array method. We have the print array method. We have our sum method. And then we have our main. But here I did not actually call the method sum and print out that sum from within main, whereas I did that right here in this main. All right. So what follows is processing two-dimensional arrays. And we've already done the first three. We've already created an array with random values. We've already printed arrays. We've already summed them. So let's do maybe these last two or three, or maybe we'll cover all of them. Let's sum the elements by row. This is going to be interesting. We want to sum the elements by row. So how can we do this? Let me think. So we want to, given a two-dimensional array, we want to loop over all of the rows. And for each row, we want to sum, but we want to start a new sum for each row, right? We want to reinitialize sum to 0 and only sum the elements of a given row and then print out that sum. So this time we'll do the printing within the actual array itself, within the method itself. So I'm just going to call this method sum array, sum 2D array, sum elements, or sum 2D array elements by rows. So sum by rows, and we're going to send over this address of that array we created. And I'd encourage you, maybe pause the video and see if you can come up with that. How would you sum the array by rows? So for clarity, we want to loop over that first row and we want to print its sum. Then loop over the second row and print its sum, where that's row index 1. Here, loop over this third row, row index 2, and print its sum. How would you do that? Pause the video, try to make that happen, and then come back. What I'll tell you, it's pretty straightforward. I'm going to take this right here. I'm going to copy paste the hell out of that. And now this is called sum by rows. And we need to loop over each row. For each row, I should have changed this comment above. loop over each cell, that's fine. Okay, now for each row, or loop over each cell in the row and add its value to sum, which we've done, right? This looks like the previous sum one, but the difference is what? Re-initialize sum to 0 for each row. So sum equals 0 right here. So I'll even make this sum outside. No need to initialize it. I'll declare it. But now, at the beginning of each row, I need to set sum to 0. And now, after each row, we sum each row, print that sum. So I can delete this. I'm not going to return anything. In fact, the return type is going to be void. And what I'm going to do here is print out that result. So let's print, as a formatted printing, the sum of row %d is %d period new line. And so what is that first %d? That's the row index number. So we can literally access it just with row. So the sum of row is our variable name from the for loop, is, and now we just print out sum. So let's see if this even works. The sum of row 0 is 580. Sum of index of row 1 is 512, 529, 526, 477. Tempted to pause the video, make sure that that's working good. It's working good. That's just fine. So here's how we can sum all of those elements by row. How could you have summed all of those elements by column now? That's a little bit different, because here what we did summing by rows, we looped over all the rows. And for each row, we looped over all the cells in that row. What if instead of summing this way, instead we said, let's sum up all the cells in the first column, or column index 0. Then sum up all of the values in the cells of column index 1, right? Then sum up all of the cells in column index 2, and so on. How do we do that one? Let's put a new line in this method just to separate the data. And let's put a new line down here as well. Let's run this again, make sure it looks clean on the output. Good. So now we want to, I'm going to highlight this, and we want to sum the 2D array elements by columns. So sum by columns here is going to be our new method name. So we want to sum by columns. I'm going to take this code that I already made for sum by rows. I'm going to paste it. We're going to change it to sum by columns. And now what are we going to change? The difference is, instead of looping over each row, we're going to loop over each column first, which means we're going to want to change this variable. And so let's actually even delete this I want to change this variable to column, and then I want to change this one to row. And I'm trying to think of the best way to do that. So I'm just going to do it this way. It's cheesy, but I'm going to change this one just to X, right? So now I can carefully change this one to just column. And then I'm going to come back to this X, and I'm going to hit Control R, and I'm going to change this one to row. So look at what we've done. We're looping over all of the columns. And for each column, we're going to loop over all of the rows. But now what's different is when we loop over the column, we need to make sure we fix this, because this is the length of the rows, right? So now we need to be like, oh, wait, I need to loop over for column 0. Let's go back to column 0. Where were we? At column 0, let's think about this. So previously, I was looping over the number of rows. And so I had array.length to loop over that first. So now I want to loop over the number of columns. How many total columns do I have? Now this is only going to work if we have a rectangular two-dimensional array, right? This won't work for a ragged array. But so here we can just say array at index 0.length. That will give you the total number of columns. And now for this first column, I really want to loop over the number of rows in that column. Well, how many total rows are there? That's just the array.length. So this is funky, right? So we want to loop over the columns. We want to, for each column, make the sum 0. Now we want to loop over the rows. And of course, when I did that Control R and I had it flip the stuff, it flipped this, which is not what I want. I still want to put row column here because it is row first followed by col. So let's see what's going to happen. Notice we have column 0. Right? We're starting at col 0. And what are we going to do at col 0? We're going to add to the sum row 0. Sorry, row 0. Then row 1. Then row 2. Then row 3. Then row 4. That's what we've just added. So all at column 0, we added row 0, row 1, row 2, row 3, and then row 4. That's exactly what we want. And then we're going to print out that result. So let me go back to where we were here. Row column, and the sum of column %d is %d, and we're going to put column and we're going to put sum. So I think that looks good. Let's run this and see. And there we go. And if you add those values together, in fact, you'll get the result of adding those values together, which in fact is this. And let me put an extra new line right here so we can separate all of this. Really hope you all are coding with me. All right, which row has the largest sum? We could do that one, but that's really going to be doing what? If you want to know which of these rows has the largest sum, well, you need to sum each row. And then you need to take that sum, compare it to a maximum value that you would have initialized to something very small. If it's better than your previous max, well, we now have a new maximum row sum, and we can save that, ultimately return it. We can code that quickly. It's pretty easy. So which row has the maximum sum? So we'll print, make this a printf. The row with the maximum sum is row index %d period new line, and row with maximum sum is the name of the method we're going to make, and we're going to send over to it that address. So we're going to use the overall looping structure of looping over the rows. For each row, loop over all the cells in that row, add them together. So it makes sense to start with this method, sum by rows. So here's the sum by rows method. I'm going to paste it, and I want to rename it to row with maximum sum. So row with maximum sum, and we need to return an integer, which is the index of that row. So let's look at what we have here. We have int sum. We're calculating the sum. We're not going to print anything now. But instead of after we sum each row, we need to do what? We need to compare that sum to the current max. What do I want to call this? We're trying to find the maximum row sum. So max row sum. Sure. So I need to say if our current sum is greater than max row sum, and we haven't made that variable yet, what are we going to do? We're going to save max, we're going to save sum into max row sum. So we need to make this variable int max row sum, and we need to initialize it because we're going to be comparing the very first row, we're going to be comparing it to this. Hey, did we find something bigger? Well, what do we initialize this to? You want to initialize it to a small value. In fact, you want to initialize it to such a small value that everything's guaranteed to be larger than it. So what you do the best way, or best practice, is to initialize this to integer dot min value. So that's going to be the smallest possible thing. So the first time that we execute this if statement, you can be sure this will be larger. So we have found a sum. It's greater than our max row sum. So perfect, save the sum into it. But we're not trying to return the sum. We're trying to return the row with that maximum sum. So let's make a new variable, int row with max sum. And let's just initialize this to -1 because this is going to be, we're going to return the row index. I'll even call it row index with maximum sum. There is no -1 index, so it's okay to choose -1. We need to choose something smaller than 0. I could have started at 0. That would have been fine as well. So here, if this is ever true and we found a new maximum row, well, we need to record which row was that. And the answer is this was row from this outer for loop. If we're at row 0 and that was the new maximum sum, we'll save it there. Was row 1 bigger? No, row 1's not bigger. Row 2? No, it's not bigger. Row 3, was row 3 bigger? Well, let's look at this. It just so happens none's bigger than row index 0 because row index 0 had the largest one. Hypothetically, or not hypothetically, let's actually change the code. We'll put a new seed and we'll look at this. But currently row index 0 will have the maximum sum. So let's go ahead and when we're done, return. Here we are, and I want to return the index of the row with the maximum sum. Notice the commenting we're putting in here, it's very clear. Of course, I need to type a return value. Or return row index with maximum sum, and we run this code, boom. Beautiful. And which is the row index, or the row with the maximum sum is row index 0. Let us change in our create array method. Let us change the seed to how about we choose, I'm looking at the time, it says 10:22. Let's put 1022. Run it. So now if you look, the row here with the maximum sum, we can visually see that it's row index 1 with the sum of 576, and indeed that is correct as well. So the final thing it said was row random shuffling, which we did with a one-dimensional array as well. We can do that here. All we'd be doing is, previously we generated 2 random indices and we swapped the values within a row of those 2 random indices. Here we would just swap, we could make 4 random indices for a random, we could make a random column and a random index, and we could swap that with the row and column index within 2 nested for loops. But all of these are doing the same thing. So I'm looking at the length here, I'm going to be cognizant of time. That's going to really be doing the exact same thing we've already seen, so no need to go through that one. It's just more practice with what? All of these are doing what? Practicing these 2 for loops where we have the outer one looping over the rows, the inner one looping over the columns, with that one exception of this sum by column one, which where here we looped over the columns first and then looped over the rows. But in general, getting more and more comfortable with 2-dimensional arrays and processing them, adding the values up, looping over the rows and then the columns or vice versa. That's really the objective. Hopefully we've accomplished that. What I'm just skipping through here is what I just coded live on this video. And then we have some checkpoints here. I want to look over each one briefly, just so we can give you a chance to maybe pause the video and perhaps code this and take a guess of what this would be, because it's such an important skill to be able to look at this code and to be able to spend, might take 3 minutes, but to really process, okay, what's going on, what's being printed. I see this 2-dimensional array. We got 3 rows, 2 values per row. What am I looping over? Look at that outer for loop, look at that inner for loop, and try to determine what's being printed. Super important. Here's another example. Got that. We have another 2-dimensional array, the same array in fact. What are we summing here? Because we only have 1 for loop. Think about what's being summed. This is another one to practice. Reach out, leave a comment, ask questions, leave a comment with your answer perhaps. And then finally, we have one more. And this is a very nice one to think about what's going on. And this one I wanted to spend about 20 to 30 seconds on. Look, we have this 2-dimensional array, 2 rows, and each row has 4 values. We have this method M1 that receives a 2-dimensional array. And what does it do? Well, the first thing it does is it makes a 1-dimensional array of size 2 called result. And then it says a result at index 0 is m.length. No problem. It takes the length of that 2-dimensional array, which is the number of rows. It saves it to index 0. So now index 0, for this example, will store a 2. And then it saves at index 1 of result what? It saves at index 1 the length of row 0 of that two-dimensional array that was sent over, which is going to be length 4. That's the number of columns in that row. And then we return result, and we're returning what? A one-dimensional array. So what's funky? I said that quickly. You might have to pause and go back. But what's funky is, check this out. What are we printing? Well, here we're printing, and we call array M1. We call method M1. We send over this array to method M1. And what does method M1 return? It returns a one-dimensional array of values, but it returns an address, right? When we say return int bracket, we're returning an address. And imagine that all of this M1 array is now replaced with an address of a one-dimensional array. And this says print index 0 at that address. Print index 1 at that address. Super funky. We'll cover that again. We're over time for the video. It's been fun. As always, reach out if you have any questions. Leave a comment. Take care.